What's up, guys? So moving on to the next example for the long division of polynomials. We got this 4x cubed minus 8x plus 3, and we're dividing it by x plus 2. Now, in the examples that we did before, we always had a leading coefficient for every degree in the polynomial. But notice now how in the dividend there is no term for x squared. So whenever you run into a situation like this, you want to rewrite whether the dividend or the divisor, and for any degree that's missing, you want to put a 0 as a leading coefficient. So in this case, x squared is missing, so we would put plus 0x squared minus 8x plus 3 divided by x plus 2. And the reason that we do this is because when we do our division and we're doing our vertical subtraction, it's going to be a lot easier to do. So a recap, any exponents that are missing, any degrees that are missing in the polynomial, whether the dividend or the divisor, you want to rewrite the dividend or the divisor and just sub in a 0 as the leading coefficient for the degree that's missing. In this case, it was an x squared. So I just took this division and I rewrote it here, and I'm using our new dividend with our 0x squared as well. And now the process is just the same. So we find out how many times does x go into 4x cubed. So 4x cubed divided by x, well, that ends up being 4x squared. So 4x squared goes here. 4x squared times x is 4x cubed. And then 4x squared times 2 is 8x squared. And then when we subtract the dividend, this term from the dividend, 4x cubed minus 4x cubed, that nets out to 0. And 0x squared minus 8x squared ends up giving us negative 8x squared. So notice how this 0x squared here, it made the subtraction here easier to see. And then we just bring down the negative 8x plus 3. Now we're going to make sure that this negative 8x squared minus 8x plus 3 is correct, so we're going to do the subtraction on the side. As I mentioned in the previous videos, I highly suggest you start doing this just to make sure that there are no algebraic mistakes. So 4x cubed plus 0x squared minus 8x plus 3 we rewrite, and then this negative 1 we distribute it inside the bracket, so we end up having negative 4x cubed minus 8x squared. So 4x cubed minus 4x cubed, that nets out to 0. 0x squared minus 8x squared, that ends up giving us negative 8x squared. And then the negative 8x plus 3 we rewrite as is. And that's the same result that we got. So now we check how many times does x go into negative 8x squared. So negative 8x squared divided by x, that ends up giving us negative 8x. So negative 8x goes here. Negative 8x times x is negative 8x squared. Negative 8x times 2, that's negative 16x. So when we subtract these, the negative 8x squared minus negative 8x squared, those cancel out to 0. Negative 8x minus negative 16x is the same as negative 8x plus 16x, which gives us positive 8x. And then bring the 3 down, that gives us 8x plus 3. So doing this subtraction here on the side just to make sure we didn't do any mistakes. So this negative 8x squared minus 8x plus 3 minus this negative 8x squared minus 16x. So if we do this here, distribute the negative 1 in, that ends up being plus 8x squared. Negative 1 times negative 16, that's positive 16x. So negative 8x squared plus 8x squared, that nets out to 0. Negative 8x plus 16x, those are like terms, that ends up being 8x, and then plus 3. So then we find out how many times does x go into 8x. So 8x divided by x, well, the x's just cancel out and we're just left with 8. So 8 times x plus 2, that ends up giving us 8x plus 16. Then when we subtract these, the 8x's cancel out. 3 minus 16 ends up giving us negative 13. And x plus 2 can't go into negative 13, so negative 13 is our remainder. So taking this result here and then rewriting it in a division statement, our dividend of 4x cubed minus 8x plus 3 is equal to our divisor x plus 2 times our quotient of 4x squared minus 8x plus 8 minus our remainder of 13. So as a recap, the trick in this question was that in the dividend, there was no term for x squared. And whenever there are any terms missing, you always want to add a leading coefficient of 0 and add that term in. So when you do the long division, the vertical subtraction is a lot smoother and it's a lot easier to see. So in this case, there was an x squared missing from the dividend, so we put in this 0x squared. But other than that, process is exactly the same.